The next section on parallelograms we're going to talk about are special parallelograms. The first special parallelogram that we're going to look at is a rhombus. We defined a rhombus earlier as being a four-sided figure where all four sides are congruent, and now we want to also say that opposite angles are congruent. Now, a rhombus, being all four sides being congruent, can also be considered a square. A square is a type of a rhombus. So in a square, opposite angles are congruent. They're all 90. So the 90-degree angle opposite from the 90 is equal to each other. But if I'm talking directly just about a rhombus that is not a square, the opposite angles are congruent. So we're going to look into Theorem 1 first. Theorem 1 states that each diagonal of a rhombus bisects two angles of the rhombus. So what I have here is an illustration of the rhombus. All four sides are congruent, and I have a diagonal drawn that's dividing this rhombus into two separate triangles. By doing this, it's bisecting these angles of the rhombus in half. Now we know, based on the definition up here, that opposite angles are congruent. So whatever the combination of 1 and 2 are here, let's say that angles 1 plus 2 equal 50 degrees. That means that angles 3 plus 4 would also equal 50. But when the diagonal is drawn here, it's bisecting it into half. So now angle 1 and 2 are equal, and angles 3 and 4 are equal to each other. Theorem 2 is talking about the diagonals of a rhombus and saying that the diagonals of a rhombus are perpendicular to one another. So if I draw both of these different diagonals within my rhombus, I'm stating that A to C is perpendicular with B to D. So not only are these diagonals bisecting the angles in the corners, but they're also, when they cross each other, dividing each other into four 90-degree angles here. So Theorem 2 states that diagonals of a rhombus are actually perpendicular with one another. The third theorem is that the diagonals of a rectangle are congruent. So now we're going to focus on rectangles as being my next special parallelogram. So within this rectangle here, I have A, B, C, D, and the diagonals that are drawn from A to C and from B to D are congruent. Now the reason that they are congruent here and they are not congruent within my rhombus is because of the angle measurements. Inside of a rhombus, I have two acute angles and two obtuse angles. The length between the acute angles is usually a longer diagonal. Think as if you had this rectangle here and you took these angles and you stretched them to make them acute. While you stretched them, that diagonal would grow, and if you push this in to make them more obtuse, this diagonal would get smaller. So that's why the diagonals are not congruent in a rhombus. But in a rectangle, all the angles are the same. They are all right angles. So because of that, these diagonal lines here are going to be the exact same length. So if A to C was 20 units, B to D would also be 20 units. So those are the three theorems that we will talk about when dealing with rhombuses and rectangles. So now we're going to look at a couple examples of problems that will be similar to ones that we will do in your assessment in class. Example 1 asks me to find the measures of the numbered angles within the rhombus. Okay, the different things that we learned about the rhombus. The first thing was the diagonals, when they cross, are perpendicular. So if we know that, then that means that angle 4 here would have to be a 90-degree angle. Alright, we also learned that opposite angles are congruent to one another and that the diagonals bisect each angle. So if this is a 40-degree angle here, that means that this would be 40 degrees and this entire angle here would be 80. Which means that if opposite angles are congruent, then this angle would also be 80 degrees. So if I want to find the measurement of angle 2 here, that would be half of that 80 degrees, which would be 40 degrees. Now if I have 40 degrees here, I have 90 where angle 4 is, and I know for a fact that there are 180 degrees in every triangle, I can find angle 3 by finding the sum of 90 and 40, which is 130, and then angle 3 has to satisfy that 180 degrees, so it must be 50 degrees. So angle 3 would be 50. And for the same reason why angle 2 was 40 degrees, you can think back on your parallel lines and your transversal and alternate interior angles being equal. So whatever the value of 3 is, angle 1 will also be the same. So that is finding the measures of the numbered angles within this rhombus. Okay, example 2 is a question about a rectangle. And it says that LMNP is a rectangle. Find the value of x in the length of each diagonal if ln equals 9x minus 14 and mp equals 7x plus 4. So always illustrate what they are trying to tell you if it's just a simple word problem. Give yourself a picture to go off of, because it might make it a lot easier for you to understand what they're asking you. So they say that this rectangle's name is LMNP. So you should be able to write that in that order. And then they say from L to N is 9x minus 14. From M to P is 7x plus 4. Well, we learned that in a rectangle, these diagonals are congruent by that third theorem before. So what I'll do with these equations are just set them equal to each other. 9x minus 14 is equal to 7x plus 4. I will go through my algebraic process of solving for x, so subtracting 7x from both sides to eliminate x on the right side of my equation, adding 14 to go again through the process of isolating x and eliminating that negative 14. So now I'll end up with 2x equals 18, so my value of x needs to be 9. Now, a lot of you might stop here on a test if you did not read the full question. The full question asked me not only to find the value of x, but also the length of each diagonal. So I need to go in. It doesn't matter what equation I plug this 9 into, because they're both equal to each other. If I plugged it into ln, I get 81 minus 14. If I plugged it into mp, I get 63 plus 4. Either way, I'd come up with the fact that those diagonal lengths, ln and mp, are both going to be equal to 67. The one example I want you to do tonight to bring to class is to find the value of the variables in the rhombus here. So we have this angle here is a 90-degree angle. So I want you to figure out what x and z would be if angle 1, the measure of angle 1, is 3y minus 6. So this is a 90-degree angle, and that's your angle 1. So again, this is a rhombus. All sides here are congruent. So find out the value of all the variables of y, of z, and of x. So again, this has been covering special parallelograms, which include rhombuses and rectangles.